Hi everyone, we are a team of two, Pavan and Shankar. I am Shankar. Yeah, our project title is Real-Time Fraud Detection System using Confluent Kafka, Apache Flink SQL, and Google Gemini. The goal is simple: detect and block fraud before the payments complete. Yeah, the problem with the traditional fraud detection system, most systems use batch processing, so fraud is detected 2 to 24 hours later. Payments are already completed. Business lose millions every year. This delay exactly what our system eliminates. So our solution is real-time streaming plus AI. We analyze transactions as they happen, make decisions before the payment complete, and do everything in under 500 milliseconds. And on the point in the data flow, we use a transaction generator and Kafka. Here we simulate real users transactions. This includes user ID, merchant ID, amount, timestamp. All the transactions sent to a Kafka topic called a raw transaction, which acts like a real-time event backbone. And then we process the transactions, like real-time processing of transactions. This is where Apache Flink code process the stream. In real-time, Flink categorizes a transaction amount, calculates user velocity, applies the time window aggregations. The output is an enriched transaction stream with fraud indicators. Here we can see that. Let me show. Here is the fraud detection. Yeah, here is the transaction generator code. Let me run this. Here transactions are generated like real-time transactions, which include user ID, merchant ID, and the timestamp. Let's see them. Here is the complete cloud. Yeah, we are going to the topic where we have discussed Kafka topic. Here is the rare transactions topic. Here we can see the transactions which are generating. Yeah, here the transactions are generating. These values are stored as a JSON in JSON format. Yeah, you can see that. Yeah, here is the timestamp, the key user ID, and the values. Yeah, let's after that we said yeah, the Flink SQL is categorize the transactions based on amount, user velocity, and time window aggregation. Here is that. Let's get into the enriched transactions. Yeah, here you can see the transaction being generated under the classification which we have provided in the Flink cloud. Yeah, after that, yeah, after that, this data is used in classifying the fraud predictions. Here we use intelligent detection hybrid AI system. This is the core intelligence of our system, where enhanced transaction is analyzed by hybrid AI system. First, like Google Gemini, we are using Google Gemini 2.0 Flash performs intelligent reasoning. If AI is enabled, a rule-based engine takes over. This guarantees 100% uptime. The system never fails. Yeah, here is the decision engine. Here we calculate a fraud score between 0 and 1. Based on the score, low risk is approved, medium risk is sent for the review, high risk is immediately blocked. This ensures the fast and explainable decisions. Let me show that. Here is the fraud predictions code. Let me run this. Yeah, now it began to classify the predictions. Let me check that. Let's go to the Kafka topics. Fraud prediction, little fraud predictions. Here we can see the messages which are classified. Yeah, here we can see that these are classified. Now the main real thing is to streaming of data. Here we use FastAPI as a backend. So the final decision is published into the Kafka topic, and then a FastAPI streams the result via web sockets to a live dashboard. So live transactions and the fraud scores, the decision updating in real time. Yeah, let's see that. Let me run this backend. Yeah, here you can see that. Let me go and check it. See, here the backend is running. Let me check in the that backend if the system is running or not. Yeah, here you can see it is running. It has been classified the transactions. So let these classified transactions will be streamed real time in the dashboard, the front end dashboard. Let me do that. Here is the index.html where we have used Tailwind CSS for the design of dashboard. Let me run this one. Yeah, and then I will bind it to the backend. HTTP and bind it to the backend, which is 127.0.0.1. Okay, sorry. Python space and space HTTP server, and then we are running in the 3000 port, and then bind it to the backend, which is 127.0.0.1. Yeah, here you can see the index.html is running. Yeah, here you can see the results. Here, see the live transaction stream where the fraud predictions are being done. Here is the fraud rate of the transactions. See, here the hybrid AI system classifies the rule based and the AI based predictions. Yeah, here are the total number of transactions. Yeah, we can see these are up to time according to the front end and the back end. Yeah, these are the results of this project.